Let's practice finding the LCM, or least common multiple, of two given numbers together. Specifically in this video, we're going to use two different methods. The first one's going to be the prime factorization method, and the second one is going to be the ladder, or the cake method. And for each of these practice problems, let's try and use the ladder method first, and then the prime factorization method second. So for number one, we have 4 and 3, so we're going to start by just writing these two numbers next to each other, just like this. And if we have 4 and 3, what goes into both of them? I think I can only think of a 1 here. 1 goes into 4 4 times, and 1 goes into 3 3 times, and I think we're going to have to stop here. Now the 1 on the side, this would be our GCF, but if we go ahead and we multiply everything along the outside, kind of something that makes this L shape for LCM, this will get us our least common multiple, right? So along the way here, we have this 1, that would get us our GCF, but if we go ahead and multiply by the 4 and the 3, right, then that's going to get us our LCM. So I'm just going to underline using this color for the GCF each time, and I'm going to underline all of these will get us our LCM. So we actually find the GCF along the way. So 1 times 4 is 4, 4 times 3 is 12. So we can say here that the LCM, or the least common multiple, of 4 and 3 is going to be 12. That's the first time they meet. Now let's try using our prime factorization method. So we have 4 and 3. So 4 is just going to equal 2 times 2. Those are its prime factorizations. And then for 3, 3 is a prime number, so we just go ahead and write 3. Right? So notice they have nothing in common, but in this case, you can always put a 1 as well, right? So if you go ahead and write times 1, you can see that would be their GCF. And then you can notice that everything else is technically an extra number. So if you multiply 2 times 2 times 3, that's going to also get you your LCM. So right here, you can notice here 1 would be the GCF, and then you have your extra numbers of 2 and 2 and 3. These ones did not have anything in common, and that gets you your LCM of 12, and then that checks out, so everything must have been good. For number 2, we have the numbers 8 and 12, so let's see how that one's going to work. Again, I'm going to start with the ladder method just to give that one a go first, so 8 and 12. Now thinking of a number that goes into both, maybe we'll just start with 2. 2 goes into 8 4 times, and 2 goes into 12 6 times. Then 4 and 6 I think still have something in common. They still have a 2. So 2 times 2 is 4, and 2 times 3 is going to be 6. Okay. Now if we take a look on the side here, this 2 times 2 on the left side, that's going to get our GCF along the way. But again, we're looking for the LCM here. So let's go ahead and multiply that by these numbers on the bottom. So we have this 2 times 2 times 2 times 3. So again, when we find our LCM, we can start with our GCF. So we know that's going to be 2 times 2. And then we're also going to multiply by everything on the bottom, which is going to be a 2 and a 3. So everything together here will get us our LCM. So let's think about this. We have 2 times 2, which is 4, times 2 is going to be 8, times 3 is 24. So the LCM, or the first time that 8 and 12 meet, would be 24. All right, that would be our LCM. And using our other method here for our prime factorization, 8 is equivalent to 2 times 2 times 2, and 12 is the same thing as 2 times 2 times 3. So remember, while we're finding the LCM, we'll find the GCF along the way. So they have these 2's, we go ahead and write it once. They have another pair of 2's, we go ahead and write it once. Then we have this extra 2 and this extra 3. So let's go ahead and multiply by this extra 2 and extra 3. And all this together should get us our LCM. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So there we have our LCM using another method. Okay, moving on to number 3, we have 6 and 10. Let's go ahead and use the ladder method first. So 6 and 10 next to each other. And we can go ahead and create our ladder, or our cake. 2 goes into both because they're both even. 3 and 5 times. I think that is it though. We can't go any further. On the left side, we have our 2. That's going to be our GCF. I'm going to put that down here. But what about the rest of it? To find the LCM, remember, it's everything multiplied together. So it's going to be this 2 times 3 times 5. And so let's go ahead and put that 3 and 5 into this multiplication sentence, right? So this 2 right here will be our GCF, and then everything multiplied together here will be our LCM. So 2 times 3 is 6, 6 times 5 is going to be 30. So we can go ahead and just write the LCM here is equal to 30. Okay, the first time that 6 and 10 meet is going to be at 30. Okay, and every 30 after that, they will meet their multiples. For the prime factorization method, we have the 6. 6 breaks down into 2 and 3, that is prime factorization. And then 10 will break down into 2 times 5. All right, so what do they have in common? Well, you can see here that they both have a 2. So let's go ahead and write that down one time. and they have some extra things afterwards. So our extras are 3 and 5. Those were the non-common ones, so we just write 3 and 5. And notice, just like we did in the last one, that this will get us our LCM. So 2 times 3 is 6, 6 times 5 is going to be 30. So this whole thing is going to equal 30, and so this checks out. For number 4, we have 15 and 9. So let's go ahead and write those next to each other. And what does 15 and 9 both have in common? If you're thinking of 3, that's what I was thinking of. 3 times 5 is 15. 3 times 3 is going to be equal to 9. Now this 3 on the side will be our GCF, right? I think 5 and 3 have nothing else in common. But if we go ahead and multiply everything along the outside, that should give us our LCM. So 3 times 5 times 3. So let's go ahead and just put this 5 and 3 in the multiplication sentence as well. So this 3 is going to be the GCF. However, we were looking for the LCM, so we're going to use all of this. So 3 times 5 is 15. 15 times 3 is going to be 45. So we know that the first time 15 and 9 meet is going to be at 45. All right, cool. So that's using the ladder method, and let's go ahead and use the prime factorization just to make sure this all makes sense. So for 15, that breaks into 3 times 5. And then for 9, that's going to break into 3 times 3. So let's see what they have in common. They both have a 3. Cool, so let's go ahead and write the 3. And then the ones they don't have in common are 5 and 3. So we just go ahead and multiply by 5 and 3 afterwards. Then 3 times 5 is going to be 15. 15 times 3 is 45. Or if you prefer to do 3 times 3 first to get 9, 9 times 5 is 45. You can do that as well. So you can see that's the first time they're going to meet. For number 5, let's see what we got going on here. For number 5, we have 12 and 6. So let's go ahead and set this up. We have 12 and 6. And let's see what goes into both of these. We can start with maybe a 2 if you'd like to. So 2 times 6 is 12. 2 times 3 is 6. And 6 and 3, I know it's a little bit weird, but you should use a 3 here, right? It can be one of the numbers, that's fine. 3 times 2 is 6, and 3 times 1 is going to be 3. And so I think we can't go any smaller because we have a 1 for one of the numbers. These numbers on the side, this 2 times 3 will get us our GCF. So the GCF here is going to be 6. And then if we go ahead and multiply everything together along the outside, that should get us our LCM. So this is going to be 6 along the outside times 2 times 1. So let's go ahead and multiply this by 2 by 1. And so this 6 is the GCF, as we already noted. And then this 6 times 2 times 1 will get us our LCM. So 6 times 2 is 12. 12 times 1 is still 12. So the LCM, or least common multiple, is 12. All right, so the first multiple of 12 is 12, and the second multiple of 6 is 12, so that checks out. If we want to go ahead and use the prime factorization method, 12 is equal to 2 times 2 times 3, and then 6 is equal to 2 times 3. Now what do they have in common? Looks like they both have a 2, so we're going to go ahead and write that one time, and they both have a 3, so we can go ahead and write that one time. And then they have one extra number. That extra number is a 2. So we're going to write times 2 afterwards. And then so if we look at this and say, okay, 2 times 3 is 6, 6 times 2 is 12, then we do get the LCM to equal 12, which matches what we got earlier. For number 6, we have 7 and 10. So 7 and 10 next to each other using the ladder method. And it looks like 7 and 10, the only thing they have I can think of is going to be 1. So 1 goes into each of these 7 and 10 times. Now 1 is going to be the GCF, so we can go ahead and write that, I guess, right here. That's a 1, right? And then multiply everything along the outside. That should get us our LCM. So that means 7 and 10 were relatively prime. So I'm just going to go ahead and multiply this by the 7 and by the 10 afterwards. Okay, so this 1 was the GCF, and then the LCM is just going to be everything that we multiply right here. So 1 times 7 is 7, 7 times 10 is 70. So keep in mind, when two numbers are relatively prime, that's the only time they meet for the first time when you just find their product, or if you just multiply them. So 70 is the first time they meet because 7 and 10 had nothing in common besides 1. Okay, using the prime factorization method, this should check out again. So if we take the 7, 7's prime factorization is just 7, and then 10's prime factorization is just 2 times 5. And just like we were expecting, they have nothing in common. So if you want to go ahead and write times 1, you can see there that the GCF would be 1, like we said a moment ago, and then everything's an extra, right? So if everything's an extra, you multiply them all together. We have times 7 times 2 times 5. So everything multiplied together will just be 70. All right, so everything checks out. For number 7, we have 16 and 12. Let's go ahead and write those down. And 16 and 12 are both even numbers, so we can divide by 2, but I think if you know your 4 times tables, 4 is going to be faster. So 4 times 4 is 16, and 4 times 3 is equal to 12. 4 and 3 are relatively prime, so this 4 along the side here, that's going to be our GCF. And then if we multiply everything along the outside, that should get us our LCM. So we'll draw that L for the LCM. Okay, so let's go ahead and put the times 4 times 3. So we know 4 is the GCF. But then the product of all of these prime factors, or these factors rather, are going to get us our LCM. So you can do 4 times 4 is 16, then 16 times 3 is 48, or you can do 3 times 4 is 12, 12 times 4 is 48. That's a little easier for me. So I'm going to say that LCM is equal to 48. So that's going to be the first time 16 and 12 meet. Now using prime factorizations, if we take 16, that's actually going to break into a 2 times 2 times 2 times 2. Feel free to make a prime factorization tree if that's helpful. And then for 12, that's going to break into 2 times 2 times 3. And so what do they have in common? Well, they have a 2 in common. That's part of the GCF. They have another 2 in common, and that I think finishes the GCF. And then what are all the extra prime factors? It's 2, 2, and 3. So if we put that in the multiplication sentence, 2, 2, 3, we can find here that 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3. That does get us 48. And you can multiply in a different order if you didn't like that. All right, so that checks out. And so we have number 8, we can take a look at. Number 8, we have 10 and 15. So we have 10, 15 next to each other. They're both ending in 5 or 0, so based on our divisibility rules, we can start with a 5. 5 times 2 is 10, 5 times 3 is 15. I think 2 and 3 are now relatively prime, so 5 would be our GCF. And then everything extra, let's multiply for this big L for the LCM. So let's go ahead and multiply this 5, or GCF rather, by our 2 and 3. So this right here, GCF, all together LCM. So 2 times 5 is 10, times 3 is 30. So the least common multiple here is going to be 30. It's the first number, or the smallest number, that 10 and 15 meet at in terms of their multiples. Writing their prime factorizations, we have 10. 10 is just equal to 2 times 5, and then 15 is going to be equal to 3 times 5. So what do they have in common? They have a 5 in common, which hopefully makes sense based on what we just did. So we'll go ahead and write down that 5, and then we have some extra ones that were not used. So this 2 and this 3, they're useful for finding the LCM. And so multiplying all these together, we'll get the LCM. So this makes 10. 10 times 3, that's going to be 30. And this makes sense, hopefully. All right, on to number 9. We have 14 and 21. So I don't know my multiples of 14 and 21 terribly well, but we can find out the LCM pretty quickly, I think, because if you're thinking of common factors first, that should help us narrow it down. So 14 and 21 both have 7, right? 7 times 2 is 14, and 7 times 3 is 21. So the 7 on the side is going to be our GCF. I believe that's done. And then if we multiply everything along the outside here, 7 times 2 times 3, that should get us our LCM. So let's put the 2 and the 3 into the multiplication sentence. And so 7 is going to be the GCF. And then 7 times 2 times 3 will get us our LCM. All right, now you could say 7 times 2 is 14, 14 times 3, it is 42, but it might make more sense to go 3 times 2 is 6, 6 times 7 is 42, just because that's a little bit easier to multiply. So feel free to change up the order, but 42 is going to be the first time these numbers meet. Then trying our prime factorization method, 14 is the same thing as 2 times 7, and then 21 is going to be the same thing as 3 times 7. Okay, so if we go ahead and notice these are common, then that would be our GCF. And then our extras are this 2 and this 3. If we go ahead and apply those, times 2 times 3, altogether this is also going to equal 42. So feel free to multiply these out just to check it. If you need to pause, feel free to do so as well. But both methods get us 42. For number 10, we have 24 and 18. So I'm going to write those side by side. And let's think, what could we divide both of these by? We could use 2, right? That's a given because they're both even numbers, but maybe we could try a bigger number, so maybe something like 6. 6 times 4 is 24, and 6 times 3 is 18. So we did it in one step here, but if you needed smaller numbers, you could have used a 2 and a 3 as well. 6 would be the GCF. Let's see what other numbers we have here. So we have a 4 and a 3 left at the bottom, so if we multiply everything here together, that'll get us our LCM. So times 4 times 3. So 6 is indeed our GCF, but then everything gets us our LCM. So 6 times 4 is 24, 24 times 3, that's 72. Or we can say like 3 times 4 is 12, 12 times 6 is 72. Or if you're feeling extra fancy, 6 times 3 is 18, 18 times 4 is also 72. No matter how you do it, the LCM here is going to equal 72. Whatever works for you. Just multiply the three numbers together however you would like to. If you're using the prime factorization method, you can see how everything's going to break down. So it shows you a little bit more details. 24 is 2 times 2 times 2 times 3. And then 18 is the same thing as 2 times 3 times 3. All right, so the 2's match here, which makes sense. That was part of our GCF. And it looks like we have the 3's match here. So hopefully that makes sense because 2 and 3 make 6, which is the GCF we got. And then 2, 2, and 3 are the leftover numbers. So let's multiply 2, 2, and 3. 2 times 3 is 6, times 2 is 12, times 2 is 24, times 3 is indeed 72. So that works. For number 11, we have 13 and 5. So I can write those down and try to think about what they have in common. Now they're both prime numbers, and if they're both prime numbers, then the GCF is always going to be 1. So we have 13 and 5. So we didn't really get anywhere, but that lets us know that we can just multiply 13 times 5 to find the LCM. So again, 1 is going to be the GCF at the bottom here. And if we multiply 1 times 13 times 5, which is really just 13 times 5, that'll get us our LCM. So 1 times 13 times 5, this right here is our GCF. That's the LCM. 13 times 5 is going to be 65. So I'm going to go ahead and write the LCM is equal to 65. All right, cool. If we go ahead and write the prime factorization method, there's nothing too exciting happening here. 13 is just equal to 13, and 5, surprise, surprise, is equal to 5. So they have nothing in common, so it's sometimes just helpful just to write the 1 so you can see, okay, that they have the 1 in common, and then afterwards, everything is technically an extra, right? And by everything, I mean 13 and 5. So 1 times 13 times 5 is equal to 65. So that matches. For number 12, we have 27 and 18. So let's go ahead and write 27 and 18. Now go through your multiplication facts or your divisibility rules and think, what can you divide both of these by? The first thing that comes to mind for me is going to be 9. 9 times 3 is 27, and 9 times 2 is 18. And so if we do that, 2 and 3 are now relatively prime, so 9 would be our GCF. And then if we multiply everything on the outside together, that should get us our LCM. Okay, so let's go ahead and put the 3 and 2 onto the multiplication sentence here. Then all of this together should get us our least common multiple. Now 9 times 3 is 27. 27 times 2 is 54. And if that was a little tricky, maybe we just do 2 times 3 is 6. 6 times 9 is also 54. I think that might be easier for more people. So the least common multiple, or the first time these two numbers would meet, would be 54. All right, now if we go ahead and write their prime factorizations, 27 is the same thing as 3 times 3 times 3. And then 18 is going to be equal to 2 times 3 times 3. All right, so these 3's clearly match. We can write it one time. And then we see another pair of 3's. They match. We can write it one time. And then we have a couple extras. We have a 3 and a 2. So if we throw those onto this multiplication sentence as well, all this should equal 54 as well. So 3 times 3 is 9. 2 times 3 is 6. 9 times 6 is 54. Let's see what we got for number 13. For 13, we have 39 and 26. Okay, so put these side by side. And for this one, you might need to think of your divisibility rules a little bit as well, or it might help to use the prime factorization method or just make the tree first. But 39, I know you can divide by 3. It's 3 times 13. And then for 26, you can divide by 2, and that's actually 2 times 13. So again, if you weren't sure, feel free to make the prime factorizations or use the other method first. it's helpful with bigger numbers or numbers you're not sure about. But in this case, I'm just going to go ahead and do this since I know my 13 times tables, at least the first few of them here. So 13 is going to be the GCF between these two. And then if we take a look and multiply all these together, this should get us our least common multiple, right? So this 3 and 2, we tack those on. Then the product of these three numbers will get us the first time they meet, right? So 13 times 3 is 39, and 39 times 2 is going to be 78, I believe. If we want to go the other way, maybe 2 times 3 is 6. 6 times 13, that is 78. So we can go ahead and write the LCM here is equal to 78. And if you need to pause and just think about the multiplication, feel free to do so. That's what's cool about having videos. You can totally pause this and think a little bit more and write out the standard algorithm if you need to just multiply. All right. Again, the ladder method's great. It's just not always helpful if you're not sure about what the facts are. So for 39, if you use a tree and you figure out that's 3 times 13, and then use a tree for 26 and say that's going to be 2 times 13, it becomes a lot more clear that the GCF is going to be 13, right? So these make 13, and then you can see these extras. So we have a 3 and a 2, and that should line up with what we just did just a moment ago. All these together are still going to get you 78, I promise. For number 14, we have 25 and 15 as our two numbers, and we're trying to figure out when the first time these two numbers meet are. So, or when it is. And so I think 5 is going to be a common factor. 5 times 5 is 25, and 5 times 3 is 15. And so this 5 here is going to be our GCF. So I'm going to put a 5. Just put that right there. And then if we multiply everything on the sides here, that should get us our LCM. So let's go ahead and do that. And so we can see here that 5 and 3 are going to be part of the multiplication sentence. And then everything here together will get us our LCM. So 5 times 5 is 25. 25 times 3 is going to be 75. So the least common multiple here is 75. All right, so if we go ahead and do that, you can see what's going on here. So if you do multiples of 25, we have 25, 50, then 75. And then for 15, we have 15, 30, 45, 60, 75. All right, so for 25, the prime factorization is pretty straightforward. It's 5 times 5. And for 15, it's very short as well. It's just 3 times 5. All right, so let's go ahead and see this 5 and 5. I'll go ahead and write it one time here. And then what are our extra numbers? The extras are 5 and 3. They weren't important for the GCF, but they are important for the LCM. So altogether here, this makes 75. For 15, we have 34 and 51. This is another one that I think might be tricky for a lot of people to maybe try using the ladder method first. So I'm going to do the ladder method first, and then I'll show you the prime factorization. But for 34, you can divide it by 2, and so 2 times 17 is 34. And 51, if you add 5 plus 1 is 6, so that's a multiple of 3, so we can divide it by 3. Turns out 3 times 17 is 51. So if you weren't sure, totally get it, but I'm telling you right now, 17 goes into this 2 times, and 17 goes into this 3 times. And so you might have to think about divisibility rules a little bit first before you can come to that conclusion. So take your time if you're not sure, and it gets easier as you practice though. Okay, so I've just done these a lot of times. So 17 is going to be the GCF, and then we have these as our leftover numbers, so we have 2 and 3 as well. So 17 times 2 times 3 should get us our LCM. So all together here, I'm thinking I'm going to do 2 times 3 to get 6, and do 6 times 17. I think 6 times 17, 6 times 10 is 60, 6 times 7 is 42, so I think that's 102. I'm going to put the LCM here is equal to 102. All right, cool. Now if we go ahead and use our prime factorization method, this one should spell this out a little bit more, especially if you make a tree, you'll find out this is 2 times 17. And then for 51, you'll find out that's going to be 3 times 17. Right, so what do they have in common? Well, they both have 17 in common, which is great. And then they have the 2 and the 3 left over. So what they had in common was 17, and then the extras were the 2 and the 3. Altogether, that should equal 102 if you multiply all three numbers. Finally, for number 16, we have 48 and 80. So these are some bigger numbers, and we're going to figure out the first time these ones would meet. Okay, so 48 and 80. Maybe I'm thinking to start with 8 for our first number. 8 times 6 is 48. 8 times 10 is going to be 80. And then for 6 and 10, I'm thinking of a 2. 2 times 3 is 6, and 2 times 5 is 10. If we multiply this 2 and 8 on the side, that'll get us our GCF of 16, okay? And then if we go ahead and multiply all the extras, that should get us our LCM. So let's multiply that by all of these numbers on the bottom. So all together, these will get us our LCM. So let's multiply this by 3 and then multiply this by 5. Okay, so all together here, that'll get us our LCM. So it's gonna be a much bigger number than maybe in the past. Let's see, 16 times 3 is 48, and then 48 times 5 is gonna be 240. Okay, so the LCM here is 240. Feel free to pause to do that multiplication if you want to double check. Okay, and if we try our other method of prime factorization for 48, that comes out to 2 times 2 times 2 times 2 times 3. And then for 80, that's going to be 2 times 2 times 2 times 2 times 5. All right, so what do they have in common? They both have a 2 right at one time. They both have another 2 right at one time. They both have another 2 right at another time. And they have a fourth 2. So that gets us our GCF of 16. And then we have our 3 and our 5 afterwards. So 3 times 5. Altogether, if you multiply these together, I promise you'll also get 240. All right, so there you have 16 different practice problems on how to find the LCM using 2 different methods. They're both good ones, and you can choose which one you find to be more helpful. But there's also something I didn't talk about that I'll show you right now that you can also use to find the LCM once you're done the ladder method or done the prime factorization method. And that is if you go through each of these, you can notice another pattern. So 48 times the leftover number here also gets you the LCM, and 80 times the leftover number here also gets you the LCM. Or you can think about this as 80 times 3 is the same thing as 48 times 5. That's going to be 240. If you look back at each of these examples, I promise you it always works. So 27 times 2 is 54. 18 times 3 is also 54. 18 times 3 is 54. 27 times 2 is also 54. So you can write this way as well and think about the LCM in this other way as well. So this is 102. So if that's easier to multiply to get this 102, then go for it. This is also 102, but I think 51 times 2 is easier. 13 times 5 is the same thing as 5 times 13. Hopefully that makes sense. Just kind of showing you a few different ones here. 25 times 3 is definitely 75. Or you can say like 15 times 5 here is also 75. 24 times 3 is the same thing as 4 times 18. Or you can see this 18 times these two 2's also make 4, right? So just a few different examples to look at. This makes 42, this makes 42. This is going to make 78. This also makes 78. Or this makes 78, and this makes 78. So kind of interesting how all these kind of patterns kind of come to be. And so if you find that helpful as well, feel free to use it as a shortcut. If you found this video helpful, please consider giving it a thumbs up. It helps out the channel. And as always, keep up the great work, and I'll see you in the next one.